Code review is the process of reviewing the code, not by the developer who wrote that piece of code, but by some other developer from the team. How it helps? It not only brings a fresh perspective, but also promotes knowledge sharing. And here, knowledge does not necessarily mean only the programming knowledge. This can be the information about the business domain as well. Such activities promotes good synergy among the team members. The code review process may be formal or informal and can involve a peer review where the code is reviewed by a team member or a more senior developer or an automated tool that checks for common errors and issues. It typically involves a thorough examination of the code for issues like syntax errors, security vulnerabilities, performance issues, maintainability, scalability, etc. And the reviewer or reviewers may also suggest improvements to the code's design, organization, its documentation, or testing. The process helps to ensure that the code is of high quality and meets the project requirements, and it also facilitates knowledge sharing among the team members. Now, the question is, if you are tasked to perform the code review, what would you look for in the code and what tools will you use? So, let's begin with the process. In a code review, there are several aspects that should be examined to ensure that the code is of quality and meets the requirements of the project. So, some of the key things to look for in a code review process, as well summarized by Daniel Bryant and Abraham Marín-Pérez in their book, Continuous Delivery in Java, are these: understandability or readability, how understandable and readable your code is. Then, language specific issues. Then, we have the security as a consideration, performance, maintainability, the style, and the overall approach to testing. So let's begin to explore them one by one. The first is understandability or readability. It's about checking that the code is easy to read and easy to understand, with clear variable and function names and appropriate use of comments. So it is said that unless you are working in an environment, working for a domain where performance is the most crucial factor, it is considered to be a best practice to even sacrifice performance for the sake of increased readability, simplicity, and understandability. That's the significance of a quality, or we can say the significance of the clean code in an application, because the cost of owning a mess is huge. It's more huge than we can even anticipate. So, at a larger level, during a code review process, one must look for certain things in a code. If we talk about the naming convention, then we must use the intention revealing names. That means the name of your variable, your function, your class, your every single entity within a code should reveal its intention as well. It's not like that the intention is X and your name is Y. So whatever you're naming, that must be intention revealing itself. Then we must also minimize any kind of disinformation while naming some certain thing, because if you give something a wrong name, then that's promote the disinformation. That very name itself promotes the disinformation. And name of your entities should be easily distinguishable. They should be pronounceable well and they should be searchable as well. Everything that has been suggested by Robert Martin in his classic book Clean Code, a handbook of agile software craftsmanship, is relevant, we can say. So, other than naming convention, the second thing that we need to consider for a better understandability of the code is minimize the accessibility of classes and members. And how we ensure that? We ensure that by proper data abstraction. Remember the open close principle that says a class should be open for extension but closed for modification. So, accessibility of your class and their members should be minimum. You should not expose more than you intend to. Third is minimize the size of classes and methods. So, for function, we generally measure the size by counting the physical lines, and for the classes, we use a different method. We count the size of a class by the number of responsibilities. A class should have only one reason to change, the single responsibility principle. So, classes and methods should be small. They should not hold more than one responsibility. That should be a goal of your code, one of the goal of your code. Next point is minimize the scope of local variables. So that means whatever variable you are declaring, its scope should be relevant. So whatever variables you are declaring locally, their scope should be limited to that particular block. And if it is not necessary, don't declare the variables at the class level. You should have a good reason to declare variables at the class level because that will affect the overall performance in terms of memory management. So if it is not needed, then declare the variable at the method level. And if it is only needed inside a particular block, let's say inside a loop or a if condition, then declare that variable inside that. So try to minimize the scope of the local variables, not to maximize that. That will help in the performance in the long term. Next is don't repeat yourself dry within a single logical component, let's say a package, a module, or a service. So that is something that we generally follow as well. Repetition is a bad practice, and redundancy in a code is a kind of a smell that we need to look for. And we must also use exception rather than esoteric error codes. And we must try to ensure that in any case, we should not return the null. That is the best practice to keep in mind. Then your code should be explainable to yourself. Explain yourself in code. So these are certain points that we must keep in mind while designing a code because the code reviewer is going to look for these certain things in your code. The next point is language specific issues. Every language has idioms for accomplishing a particular task that the majority of developers would expect to see. But often the new developers joining the team are not aware of these things. So there are also specific anti patterns that developers would not expect to see in Java. A good code review should look for these things that are related to the language. And here we are particularly talking about the Java language. Use checked exceptions for recoverable conditions and runtime exceptions for programming errors. That's the rule number one. If the conditions of a code are recoverable, then use checked exceptions. And if there are programming errors, for them, handle the runtime exceptions. Check parameters for validity as close to their specification or associated user input as possible. Indicate which parameters can be null. That's a good practice. In public classes, use accessor methods, not public fields. Refer to objects by their interfaces. Use enums instead of int constant. If you are going to need certain constants, then prefer to use the enums for that particular purpose. Use marker interfaces to define types. Synchronize access to shared mutable data. Prefer executors to tasks and threads for the multi-threaded applications. And also document the thread safety aspects in your code. So these are the language specific issues, particularly by keeping the Java in mind. Every single language have its own specific issues. One should have a checklist of the language specific issues while going through or while going to perform a code review. The next point is security. The issues of security is of vital importance. Several common mistakes can be searched during code review process, like input into a system should be checked for valid data size and range. And one must always sanitize any kind of input that is coming to you, to your application, either from a data store or a middleware or a third party system. If something is coming from the outside, you must sanitize that first, only then that particular input to let into your application, to go inside your application. Do not log highly sensitive information. That's a bad practice. Purge sensitive information from exceptions. Do not expose the file paths, internals of the system, or configurations. Consider purging highly sensitive data from memory after use. Follow the principle of least privilege. That is, we must run an application with the least privilege mode required for the correct functioning. And then finally, document the security related information. So these are some of the considerations that are well documented by the authors in their book, Continuous Delivery in Java. The next point is performance. Here, the code reviewers or the code review process should look for a good tool for detecting the obvious performance issues. But we must be aware about certain things like watch for inefficient algorithms. If there are unnecessary multiple loops, unnecessary blocks, and all that. Avoid creating unnecessary objects. Be aware of the performance penalty of string concatenation. Avoid excessive synchronization and keep synchronized blocks as small as practical because excessive synchronization will slower the pace of your application. Watch for potential deadlocks or live locks in algorithm. Anything that is going to affect the speed of your application should be should come under the category of performance and that should be checked for. Also ensure that thread pool configuration and caching is configured correctly. So these are the broad issues that one must consider while performing a code review. And I would say the developer must consider giving before handing over its code for the code review. Because if you will perform a code review by yourself first, there are chances that you will get more relevant feedback, more useful feedback during the code review process by somebody else. So look for the basics by yourself, then hand it over to the other person or the team which is going to review it, and then you will get more useful inputs from them. Other than these broader issues, we also look for the maintainability. By maintainability, we mean that the codes should be easy to maintain and update in the future. And they must adhere to the things like modular code design, separation of concern, and clear documentations. Then a style of the code must be checked as well. That there are certain established coding style and convention for the project or organization. So for a specific code review, they must be checked, including indentation, white spaces, and naming convention. Next, we have the testing. That is checking that code is adequately tested with appropriate unit test and integration test, and that the test cover all relevant scenarios and edge cases. So that's it. This is all about the code review as a process. And these are the specific things that one must keep in mind while performing such a review. In the next part, we'll talk about the tools that are available to you as a code reviewer.